In this lesson, we're going to be talking about common logs. You'll notice at the top of your note sheet it talks about base 10 logarithms are called common logs. So whenever you would have a log base 10, for example, log base 10 of 3, that's an example of a common log. When no base is given to you, you're supposed to assume that the log is a base 10. And those are one of the most common ones, which is why we're talking about them. The thing what we're going to learn to solve today is, for example, this one. If I had set this equal to x and I want to try and solve it, I would change forms, which we learned a few days ago, and I'd write 10 to the x equals 3. So then I'd try to change the bases to match up, so they're both base 3 or base 2, whatever I could find it to be. The problem is I can't match these bases up. I can't say that 10 is the same as 3 squared or 3 cubed. So that's what we're going to learn today, is how to solve them when we can't make the bases the same. The book, it says here, base 10 logs are common. When I was in school, actually, this makes me feel really old because we did have graphing calculators, but we didn't use them. They weren't as required in our classroom, so just a few of us would have them. And what you could do is your base 10 logs, we had to look up in the back of our Algebra 2 book. And so we'd go to the back of the book and look through a table. And I pulled one up just so you could kind of see what it looks like. But this is an example of what it would look like. And think of all these numbers. So it was really easy to make a mistake. So what we would do is, for example, let's say we were looking for log of 3. I would have to go into this table and I would look at 3 and go across. Okay, so when you punch in log base 3 on your calculator, so let's try that. Log is the button right below x squared. So to the left of your 7. Here, let me show you on the calculator. I'm going to go to log, and then I'm just going to punch in a 3. And this is going to give me the same number that table gave me. So see how it's 0.4771? Just so you know, when we're rounding logs, we round 4 decimal places. So you're always going to round to the 10,000th place. And that won't be told to you other than right now. That's assumed because they're decimals every time. So hundredths is not specific enough, or precise enough, I should say. So we're going to go 4 decimal places anytime they ask you to do logs. And that's pretty universal anywhere you go. So it's always known that it's 4 decimal places. So if you look at my table, so see that our answer in the calculator is 0.4771. If you look at my chart, that's the same thing I would have found here in red, the 4771. So that's what we had to do as students. If it was 3.01, let's say, the log was 3.01, then I would have gone to the 0, 1 column and come down and across from the 3, and I'd get this answer. So it gives you every decimal place at least through hundredths, and anything beyond that we would have had to estimate. Not hard to look it up on the charts, but kind of a pain, because if you looked at it wrong, you would get the problem wrong. Just like if you typed the number in your calculator wrong, now you'd get it wrong. So we're going to definitely use our calculator for this, right? So you see that I just entered log 3. It's listed here. Notice how we use the approximately symbol because we are rounding. So you should be using that. That's not something I'm going to count every problem wrong if you don't have. But if you miss it on your test and you forget it on more than like 1 or 2, I will probably take off 1 point for not remembering that you're rounding. So let's keep going and take a look. Here it says, how does this help us? So for example, the problem here, it says solve 3 to the x equals 11. This isn't something we can change the base on. So the first day we studied this chapter, we were trying to make these be the same base, because if I could make this, let's say, 3 squared, we could then say x equals 2. But I can't make an 11 be a 3 of anything, or change the 3 and the 11 to be the same base. So because of that, we use what's called the property of equality for log functions, and we take a log to both sides. That sounds kind of weird, but think about how sometimes we'll have problems like this. 1/2 x equals 6. And to solve this problem, what do? We multiply both sides by 2, right? So as long as we're doing something to both sides of the equation, it can be anything. I could choose to multiply both sides by 1,000,000. Probably wouldn't, but I could, as long as I do it to both sides of the equation. So here, the same idea applies. All we need to do is take a log to both sides. So you'll see how we wrote this as log base 10. Now remember, base 10 is our most common log. So if we don't write the base, you have to assume it's 10. So we do what we call taking a log to both sides. So you just have to write the word log. You don't have to give the base of 10. So using the power property, I would pull this x out in front. You'll notice I did that right here. And then you can divide both sides by log base 3, and you'd get your answer. So we're going to actually apply this and do it on a few problems so you can see how this works. Before we do that though, take your logs out, pause this, and then you can just copy down everything on the bottom left here, the take a log part. So pause that, and then you'll, when you're done copying, you can move on. In this problem then, you'll notice that I have 10 to the x equals 2. Can't make them the same base, so what I do is take a log to both sides. Log of 10x equals log of 2. Now I can use my power rule, so I'm working in reverse of what we did yesterday. And I would have x log of 10 equals log of 2. Divide both sides by the log of 10. And we'll get x to be approximately, and I'm going to go to my calculator, and we'll take log of 2 divided by log of 10. And I got 0.3010. And remember, we found 4 places. So I'd have approximately 0.3010. And this, I think, once you get the hang of this, this is pretty simple. I will say that normally in the past, students have thought this lesson was one of the easiest ones of the chapter. But on your test, kids get stuck on these and they think, oh my gosh, I don't know how to solve this problem. Because you have to remember to take a log to both sides. So this is the most commonly forgotten method on our test because you forget to take a log to both sides. So even though it's really easy, make sure you understand what we're doing here. The point of this is that we can't make them the same base. So we need to take a log to both sides, just like we multiply both sides by 2 to get rid of fractions. Same idea. We're doing something to both sides to help us solve this problem. So I'm going to let you guys do number 2 quick. You can pause the video, do the problem, and then check your answers with what's right here. And hopefully that is something you can do pretty simply. Number 3, I'm just making it a little bit harder, hopefully. So again, I would take a log to both sides. And then I'm going to use that power rule to move that a minus 3 out in front. And we'll divide both sides by the log of 3.1. So punch that in your calculator. Log of 9.42 divided by log of 3.1. Let me show you how I do it here. Go log of 9.42 divided by the log of 3.1. And I'm showing you this. I know you could punch this in quick. The only reason I'm showing it to you is because I want you to see that you would keep this decimal on your calculator. So I have 0.4786. So I would have a minus 3 equals approximately, sorry, I already rounded, 0.47, hold on, what did I get here? Go back. I forgot the divide symbol, you guys. Hold on. Holy buckets. Log, let's try this, 9.42. I pushed divide, I thought, but it must not have stuck. Divided by, there we go. Log of 3.1. You probably all had different answers than me, right? Better? There we go. So that's what you should have got when you did yours. So this is 1.9824. I would round up. So 1.9824. Just read that all again. Now here when I add 3, I'm going to be able to add 3 to this, no problem. But let's say this was a decimal. Make sure you're not rounding here on your calculator and you add that decimal and make it an exact answer at the end. We want to try to avoid rounding until we're all the way through our problem so we have more exact answers. And then that's what you'd get there, approximately 4.9824. So you guys go ahead and try number 4. Hopefully when you did that, that's the answer you would get for number 4, so you can check your work with that. We're going to move on to 5. Number 5 now, same idea, I take a log to both sides. So I'm going to go ahead and write it in here. Hopefully you're catching on to how you could kind of abbreviate some of your work. And so I'd have x minus 5 of log 6 equals 7x plus 2 of log 2. Now it doesn't matter which way I go here, I'm going to have to divide by a log, and you can choose whichever way you want. We're going to get the same answer either way. So I'm just going to go divide by log 6. So here I have x minus 5. Here, what I'm actually going to do is just divide the log 2 by log 6. And when I did that, I got approximately 3869. So you could do that in your calculator also. The trick here, though, is I now have to distribute this number to both of these terms. So this is an example of where you don't want to round until the very end. And I'm not going to punch all this in my calculator because mine doesn't go up and grab numbers on my smartboard. It just does my normal one does. You guys can go up and grab those numbers unrounded and use them. So when I took 7x times that 0.3869, I got 2.7080x plus, and then I took 2 times the 0.3869 and got 7737. So from here, even though it's decimals, I'm just going to simply solve this equation. So I would choose to minus 2.7x, remember I'm not going to actually round that, and then add the 5. So I ended up with negative 1.7080x equaling 5.7738 it ended up being. Now, you'll notice from here to here this changed from a 7 to an 8. That's because I did not use the rounded number. So it helped me be more precise in my answer. So make sure you are doing the same thing. So from here, I'll divide by negative 1.7080. So x is approximately negative 3.3804. Final answer. You hopefully are seeing that these aren't really hard. Kind of annoying with all the rounding and the 4 decimal places and writing all your work out, but not hard necessarily. So you're just solving the equation normally. I'm going to have you guys try this last one. Pause the video and then you can see if your answer matches mine. I'm obviously not able to get rid of my little box here. Let me just see here. There we go. They were grouped somehow. So you'll notice that I have in my answer that I got 2.67994. So I rounded, which means I just took that 4 off because it wasn't 5 or higher. Hopefully those made sense to you. The last thing we're going to do today is the change in base formula. So this is when we don't have a base 10. For example, we have just log base 4 of 25. What we would have done earlier in this chapter is we would have had this, and we'd set it equal to x, and we'd say 4 to the x equals 25. And I didn't give you any like this. All of ours we were able to make them be the same base. In these you can't, and so what you do is you'll take log 25 divided by log 4. The cool thing is, if your calculator has the update and it's a newer one, you can actually do this whole thing on your calculator by using these keystrokes. You'll go math, and then you'll hit alpha math. So that's that green button. So I would show you on my calculator, but mine doesn't have the update either. So in theory, let me just show you what this would look like. You'd go math, and then you'd hit alpha math. Now you'll notice nothing happened on mine because this is an older version. I can't update this for some reason. But if you have it on your calculator, you had something that looked like this at this point. Once you hit math, alpha math, you would have a log, and then you have a little blank, and then you have a blank right here. So what you do is just put the whole problem in. So this problem is log base 4 of 25. So to move from one spot to the next, I'm just double checking on my calculator here. It's blinking on this part right here. So I put the 4 in, and then I use my right arrow to move to the next spot. And then I go 25 and I right arrow, and when you hit enter, you should get the 2.3219. If you don't have the update, it's not like this is too much harder anyways. You're just going to take log 25 divided by log 4. So it's not really much work. It's just remembering how to do that. So I want you guys to do, well, let's just do number 1 together. Sorry. First pause and add this change in base formula to your log sheet. It's the blue right here. You can see that our sheet's almost all the way full, so you can tell we're getting towards the end of the chapter. And then go ahead and I want you to try all three of these actually. So either you're punching this in your calculator as is, or you're going to write log base 5 divided by log base 7. And you would get approximately 0.8271. So you guys do the next couple and we'll see that we got the same answer and then you're good to go. So number 2, you should have gotten approximately 1.2335. And number 3, approximately negative 1.9635. If you have a question on how to use your calculator for that, let me know, or any other questions on the lesson. Your homework for this section is in the packet I gave you for the book work, stapled packet, and the problems are listed on there. But here they are, 549, 17 through 22, 28 through 42, and 45 through 50. I don't think I have 56 on there, so ignore that.